Hello students, welcome to CET Sankalp classes. In the last class we started with waves and we discussed few of the MCQs on this chapter. So let us go for the next question today. That is on 23 question on sounding tuning fork A with another tuning fork B of frequency 384 Hz, 6 beats are produced per second. So you have two tuning fork A and B. They are of same frequency, that is 384 Hz. So what happens here? They are producing 6 beats per second. After loading the fronts of A with wax and then sounding it again with B, 4 beats are produced per second. So here what we need to calculate is, that is what is the frequency of A after applying wax to it. So here how we are going to do this means, so we have a tuning fork, two tuning forks we have. So I hope you have seen the tuning forks. It is something like this. The tuning forks will be there. So two tuning forks are there, A and B. They are of the same frequency, that is 384 Hertz. And they are producing how many beats here? 6 beats. Okay. Next, you are going to apply some wax to the fronts. This is called as, this part is called as fronts of the, this upper part is called as what? Fronts of the tuning fork. So when wax is applied to it, so again when it is when the sound is produced, so now it is producing 4 beats per second. Earlier it was producing 6, now it is producing 4 beats per second. So what is the frequency of the tuning fork of A you need to calculate. So how we can do this? That is, see here, as we know that the frequency of A and the frequency of B, how much it is giving? It is giving per second 6 bits, right? So now what we know the data, that is FA minus the frequency of B is not changing. The frequency of B, it is remaining same only, that is 384 second. They are applying that is wax to only A. Therefore, now FA is equal to 6 plus 384. So how we can do this? So this 384 plus 6 is nothing but what? 390 Hertz, 390 Hertz. So many different methods are there, but here if you use this method, this will be the shortcut one. Okay, other methods are little lengthy, therefore we can go for this method, right? So the correct option is what? Option D, that is 390 Hertz. Option D, 390 Hertz is the correct answer, right? So our next question. That is, two sound waves of slightly different frequencies propagating in the same direction, it produces beats due to. So here we have two sound waves, they are producing different frequencies when it is in the same direction. So it is because of which phenomena they are asking here. The options are interference, diffraction, polarization, refraction. So as we know that all the definitions of the phenomena, we know diffraction is nothing but what? It is bending of light. Polarization is what? That is the light is getting polarized here. Then refraction is nothing but that is the light will change the propagation when it is traveling from one medium to another medium. So interference is what? It is the superposition of two waves. Therefore, here when sound waves of slightly different frequencies, they're propagating in the same direction, it produces beats. It is due to the interference of the sound wave. It is due to the interference. Interference is nothing but what? Superposition, or the two waves are superimposing on each other. Okay, so that is option A is the correct option. Option A is the correct option here, right? Okay, let us go for the next question now. So our next question is, beats are produced with the help of of two sound waves of amplitude 3 and 5 unit. Okay. Its amplitude is given, that is 3 and 5. The ratio of maximum and minimum intensity in the beats is, here you need to calculate the maximum and minimum intensity. Okay, so as we know that the relation between intensity and the amplitude. So students, what is the relation? That is, intensity is directly proportional to the square of the amplitude here. Therefore, we can write it as, here what is there, that is maximum and minimum they have given. So intensity of maximum divided by intensity of minimum is equal to, if we take the ratio, here we can write it as A1 plus A2 when it is maximum divided by A1 minus A2 when it is minimum. So as we know, it is I is directly proportional to square, therefore here we can write it as square. This is equal to, so what is A1 value? What is, that is 5 plus A2 value is how much? 3, and A1 A2 again it is 5 minus 3 whole square. So this is equal to, that is 5 plus 3 is 8 divided by 5 minus 3 is 2. So square of that, therefore here you will get it as 16:1. Correct. So the correct option is option D. Option D is the correct option. Next. Two tuning fork have frequencies 380 and 384 Hz respectively. When they are sounded together, they produce 4 bits. After hearing the maximum sound, how long will it take to hear the minimum sound? Here what they are saying, you have again two tuning forks of different frequencies. So when they are sounded together, so when you are beating it, it is giving you 4 bits. It is producing 4 bits here. So after hearing the maximum sound, how long it will take to hear the minimum sound? As they are of different frequencies, here maximum and minimum sound will be different. Therefore, the beats period is given by, that is, the time interval between the two minimum is given by, the formula is there. It is T is equal to 1 divided by N1 minus N2. Okay. So which is equal to, 1 divided by 4 second. It is 1 divided by 4 second here. Next, the time interval between the maximum sound and the minimum sound is, as we know that the time interval between maximum and minimum sound is, it is T divided by 2, which is equal to, so here it is T is equal to 1 by 4, but we know that the maximum and minimum sound interval is 1 by 4, therefore it becomes T divided by, sorry, T value only we are substituting, that is 1 by 4, therefore it becomes 1 divided by 8 second. 1 divided by 8 second, that is option C is the correct option. Option C is the correct option here. That is 1 by 8. Okay, students, our next question is, two tuning fork A and B give 4 beats per second when sounded together. So this is similar to the first sum which we saw today in today's class. The frequency of A is 320 Hz. When some wax is added to B and it is sounded with A, 4 beats per second are given, are again here. The frequency of B is, so how you can do this? So last time how we did, no? Same way we can do this. The frequencies of A, the frequency of B. So when wax is applied, actually what happens when wax is applied, the frequency decreases here, okay? Therefore, here how we can do, that is n2 minus n1 is equal to, it is producing how many bits? That is 4 bits they are saying. Therefore, n2 is equal to n1 value, it is 320, correct? That is frequency of 8 plus 4. That is nothing but what? 324 hertz. That is nothing but 324 hertz. That is option A is the correct option. Sorry, option C is the correct option here. Next question. 41 frogs are so arranged that each produces 5 beats per second when sounded with its near fork. If the frequency of the last fork is double the frequency of first fork, then the frequencies of the first and last fork respectively. So see here, that is we have 41 frogs of are arranged and it is producing 5 beats per second. So when sounded with its near fork, if the frequency of last fork is double, here if the frequency of last is double, then the first and the last frequencies they have asked. So here we can use the concept of AP based on mathematics, that is AP concept we can use here. So how we can solve this, students, here? That is, if we consider the frequency of the first fork is as n. So here n is what? The frequency of first fork. And if we consider the frequency of last fork as 2n, then here according to AP we can write it as 2n, n plus 5, n plus 10, because it is producing 5 bits per second, plus, sorry, comma, n plus 15, so on up to 2n. So this is what, this is in the form of AP here. Now, as we know that the formula for AP is equal to, that is L is equal to A plus n minus 1 into R. So as we know that L is what? It is the last term, A is the first term, then capital N is the number of terms, and R is what? It is the common difference. So now directly we can substitute here, as we have considered the last term is what? It is 2n, which is equal to the first term is what? It is n plus n number of terms. It is given 41 frogs are there, therefore it is 41 minus 1 into R, the common difference. It is producing 5 bits per second, therefore the common difference is 5 here. If I simplify this one, it becomes n plus. So here n plus 41 minus 1, that is 40 into 5, that is 200. So here I can write here it as 200. This is equal to, so if I simplify this for n, then n is equal to, it is, so then it is becoming n is equal to, that is 200, because n 2n minus 1, it is n, therefore n is equal to what? It is 200. Therefore, we can write it for 2n is equal to, so 2n is equal to, it becomes 400. Therefore, the respective frequencies are of A and B, it is 200 and 400. That is option A is the correct option here, right? Okay, next question. In a stationary waves, antinodes are the points where there is. So as we know that there are two nodes we take, one is node and the other one is antinode, and we know what is node, what is antinode also. So based on that, you can write the answer here. So option A, it is having minimum displacement and minimum pressure change. B option, minimum displacement and maximum pressure change. C option, it is maximum displacement and maximum pressure change. Option D, maximum displacement and minimum pressure change. So as we know that, that is antinodes are what? Nodes are what? It is minimum displacement. Antinodes are what? Maximum displacement. So when the displacement is maximum, the pressure change is minimum. Therefore, the option D is the correct option here. Next question. The equation y is equal to 0.15 sine phi x cos 300t describes a stationary wave. The wavelength of the stationary wave is, you need to calculate the wavelength of the stationary wave. So we can just compare it with the standard equation and we can solve it. That is 2 pi x divided by lambda is equal to phi into x. Therefore, this is by comparing it with the standard equation, we are writing this. So in the given equation, 2 pi x by lambda is equal to, here it is phi x. Therefore, what I can write, x will get cancelled on both the sides. Therefore, we are getting it as lambda is equal to, we want, so transfer this lambda on the other side. It becomes 2 divided by phi into pi. So this is equal to, so 2 divided by 5 into pi, it is nothing but what? That is 1.256 meters, 1.256 meters. So in the given option, it is option B is the correct option. Option B is the correct option here, right? Next question. The equation of a stationary wave is, the equation of a stationary wave is y is equal to 0.8 cos pi x by 20 sine 200 pi t, where x is in centimeter, t is in second. The separation between consecutive nodes will be, the separation between the consecutive nodes will be. So the given equation, again we can compare it with the standard equation and we can simplify this like the previous one. What you need to calculate? You need to calculate the distance between the two nodes. So as we know that the distance between the two nodes is given by lambda by 2. It is lambda by 2. Between two antinodes, it is lambda. Between two nodes, it is lambda divided by 2. So we can compare the equation with the given equation with standard equation. The standard equation is y is equal to, it is a cos 2 pi x by lambda sine 2 pi v into t divided by lambda. So compare it with the standard given equation. Here 2 pi x by lambda is replaceable there. We have that is pi x divided by 20. So this implies lambda is equal to. So 2 ones are 2 tens are, therefore pi x, 2 into 20, that is 40. Pi x will get cancelled. Therefore, lambda is equal to how much you are getting? You are getting it as 40 centimeter. The distance between the two nodes is given by what? It is lambda by 2. Therefore, it is 40 by 2. Therefore, the answer is 20 centimeter. Therefore, the answer is 20 centimeter. That is option A. Option A is the correct option here, right? So just compare with the given equation, standard equation, then simplify it. Next question. Which of the property makes difference between progressive and the stationary waves? So as we know the properties of both stationary and the progressive wave, based on that we can understand this question. See, which is the difference, what is the difference between progressive and stationary wave? That is, first option is amplitude, second option is frequency, third option is propagation of energy, fourth option is phase of a wave. Here in a stationary wave, there is no transfer of energy takes place. Here there is no transfer of energy in case of a stationary wave. So the only difference between progressive and stationary wave is, that is, propagation of the energy. Propagation of the energy, that is option C is the correct option here. Okay. Next question. If amplitude of waves at distance r from a point source is A, the amplitude at a distance 2r will be. So it is again based on the amplitude and our intensity relation, as we know. Similarly, amplitude and distance relation we should know. Therefore, here we can solve it like one thing we know, that is intensity is directly proportional to square of the amplitude, and we also know that intensity is inversely proportional to the square of the distance. Therefore, by comparing these two equations, we can write it as R is inversely proportional to 1 by A, because both are square here. Therefore, we can write it as R is proportional to 1 divided by A. So now we can write R1 divided by R2 is equal to. So what is R1 divided by R2? It is nothing but A2 divided by A1. It is nothing but A2 divided by A1. We need to calculate the amplitude A2 when the amplitude and the distances are given. So A1 value is nothing but it is A. R1 value is R itself. R2 value is 2R. Therefore, R will get cancelled. Therefore, you are going to get it as A into bracket 1 divided by 2, or it is A divided by 2. That is option C is the correct option. Option C is the correct option. That is A divided by 2. Okay. Next, if two waves of same frequency and same amplitude respectively on superposition produced a resultant disturbance of the same amplitude, the wave differ in phase by. So what is there here? That is two waves of same frequency and same amplitude are there. When they are superimposed, it produces a resultant disturbance of the same amplitude. The wave differ in by phase. So the phase difference they have asked here. Okay. You can simplify it like by knowing the relation, that is the amplitude, the maximum resultant amplitude is given by resultant amplitude A is equal to under root of A1 square plus A2 square plus 2A1 A2 into cos pi. Correct. That is A is equal to root of A1 square plus A2 square plus 2A1 A2 divided into cos pi. Squaring on both the sides. So squaring on both the sides, what we are getting, it is A square is equal to A square plus A square plus 2A square into cos pi, because they are of the same amplitude. So when they are of the same amplitude, I can take it as A1 is equal to A2 is equal to what? As A. Therefore, it becomes A square is equal to A square plus A square plus 2A square. That is A into A. It is becoming A square. Therefore, 2A square cos pi. Therefore, I can simplify it like A square minus 2A square is equal to 2A square cos pi. So A square minus 2A square is minus A square. 2A square cos pi. So here again A square will get cancelled. Therefore, you are going to get it as what? Minus 1 by 2 is equal to cos pi. So therefore, pi is equal to. So when when cos pi is minus 1 by 2, when pi is equal to, it is 2 pi divided by 3. When 2 and pi is equal to 2 pi divided by 3, then it is minus 1 divided by 2. That is option B is the correct option here. Option B, that is 2 pi divided by 3. Correct. Understanding it is very, very important. Okay, students, we'll see the next question. The superposition takes place between two waves of frequency f and amplitude a, the total intensity is directly proportional to. Here we need to see the total intensity. How we can do this? As we know that the relation between intensity and amplitude, based on that we can solve it, correct? So here we can take it like that is intensity I is proportional to A1 plus A2 whole square, because they are superimposing. Therefore here what happens, the intensity we need to take it as A1 plus A2, but they are saying that A1 is equal to A2 is equal to how much? It is A itself. Therefore we can write it as what? I is proportional to A plus A. It is 2A whole square. Therefore it is nothing but 4A square. It is nothing but 4A square. Intensity is directly proportional to 4A into square. That is option D is the correct option. Next question. The following equation represent progressive transfer waves. Z1 is equal to A cos omega t minus kx. Z2 is equal to A cos omega t minus, it is plus, okay? So here Z2 value, Z1 value is A cos omega t minus kx. Z2 is equal to A cos omega t plus kx. Okay, here it is plus kx. Next, Z3 is equal to A cos omega t plus ky, and Z4 is equal to A cos 2 omega t minus 2 ky. Here they have given a transverse wave equation. 4 equations they have given. A stationary wave will be formed by superimposing. So here you need to understand by superimposing of which two waves the stationary wave is produced. See here what happens. The direction of wave must be opposite and frequency will be same. Then the superposition of standing wave formation takes place. Okay. So when two waves of same frequency but in opposite direction are there, it will produce a superposition. So options are given like Z1 and Z2. You can see Z1 and Z2, they are of the same frequency but of opposite direction, because plus and minus it is there. Z1 and Z4, it is not possible. The values are only different. Z2 and Z3 is also not possible. Then Z3 and Z4 is also not possible. Therefore, the correct option is option A is the correct option. Option A is the correct option here. Because of the same frequency and opposite direction, they will superimpose and produce a stationary wave, right? Next question. When two sound waves with a phase difference of pi by 2, and each having amplitude A and frequency omega are superimposed on each other, then the maximum amplitude and frequency resultant wave is. So here you need to calculate maximum amplitude and frequency when they are superimposed. So one concept we know that when they are superimposed, the frequency remains the same. So in the given option, either it is option B or option B here. By calculating amplitude, we will understand whether it is B or D, because the frequency is remaining constant. That is, resultant amplitude is equal to, so already we have seen the formula. It is A1 square plus A2 square plus 2A1 A2 cos pi is equal to under root of amplitude A1 value is A square plus A2 value is also A square. Therefore, here it is 2A square cos of. Here they have given the phase difference value. It is pi divided by 2. It is pi divided by 2. Therefore, if I simplify this a square plus a square, it is 2a square plus 2a square cos pi by 2. So cos pi by 2 is how much? It is 0. Therefore, this entire term becomes what? 0 here. That is a square plus a square. So a square plus a square is what? Root of 2a square. That is nothing but what? Root 2 into a. It is root 2 into a. That is option D is the correct option. That is root 2 into a into and omega, because frequency is remaining constant. Okay, next question. There is a destructive interference between two waves of wavelength lambda. So it is producing destructive wavelength. We have two interference, constructive and destructive. So here it is producing destructive interference, and the waves are having the amplitude, sorry, wavelength lambda coming from two different paths at a point. To get maximum sound or constructive interference at that point, the path of one wave is to be increased by. So how we can do this one? For destructive interference, what is the condition that we need to write first? So for destructive interference, the condition is how much? It is 2n minus 1 into lambda divided by 2. Here what they are saying, it is of wavelength lambda coming from the difference of at a point. To get the maximum and constructive interference at the point, the path difference is increased by. So if the path difference is increased by, suppose if it is increased by lambda 2, the new path difference, what I can write? The new path difference, I can write it as 2n minus 1 lambda by 2 plus lambda by 2. So for destructive interference, it is equal to n into lambda. It is n into lambda. So which is what? Which is the condition for destructive interference. It is the condition for destructive interference. Therefore, the correct option is, that is option B, that is lambda divided by 2. Okay. So you can take, means here what you can do is you can take the help of options. So with the options, you can substitute all the 4 options and you can see where you are getting the destructive interference condition, that is n into lambda, right? That is when you take when it is increased by lambda by 2, you are getting the destructive interference value n lambda. Therefore, the option B is the correct option. Okay, let us go for the next question. So next question, these questions are based on our Doppler effect. So I hope you remember the Doppler effect. See, the question is, a source of sound of frequency 90 vibrations per second. 90 vibrations per second is approaching a stationary observer. So here, source is coming towards the observer with a speed equal to 1 by 10 the speed of sound. What will be the frequency heard by the observer? So Doppler effect numericals, you can do it directly by taking the formula. Only the thing is, you need to understand which formula we need to use here. As the source is coming towards the observer, you can see the figure here. So based on the figure also you can understand. Therefore, when it is coming towards the observer, the new frequency is given by n dash is equal to V divided by V minus Vs into n. So this is equal to V divided by V minus V divided by 10 into. N value is 90 because it is 90 vibration per second. So here if I simplify this one, here if I simplify this, I will get it as 10 by 9 into 90. 10 by 9 into 90. So 10 by 9 into 90, this is nothing but what? It is 100. It is 100 vibration per second. So Doppler effect, we need to understand the formula. Directly we can substitute and calculate. So option C is the correct option. That is 100 vibrations per second. So next question is, a source of sound frequency 500 Hz is moving towards an observer with velocity 30 meter per second. The speed of the sound is 330 meter per second and the frequency heard by the observer will be. So here we have a frequency of 500 Hz is moving towards an observer. So it is moving towards an observer with a velocity of 30 meter per second. The speed of sound is 330 meter per second. Then the frequency heard will be. So here also same, it is same formula we can use and we can calculate because it is also moving towards the observer. Therefore, it is n dash is equal to V divided by V minus Vs into n. Therefore, this is equal to V value is 330 divided by 330 minus 30 into n is 500. Therefore, here if you simplify, you are going to get it as 550 Hertz. 550 Hertz. Just substitution is there. That is option A is the correct option. 550 Hertz. Right. Next question. A motor car blowing a horn of frequency 124 vibration per second. It moves with a velocity 72 km per hour towards a tall wall. The frequency of the reflected sound heard by the driver will be. So here what we need to calculate, that is a motor car blowing a horn of frequency. Its frequency is given 124 vibration per second. It moves with a velocity 72 km per hour towards a tall wall. The frequency of the reflected sound heard by the driver will be. Okay, so how we can do this? In the given condition, a source and the listener are at the same position. Okay, here the source and the listener, that is driver and the horn are at the same position. So therefore, for given condition, the formula will be it is n dash is equal to V plus, that is V of car divided by V minus V of car into n. So this is equal to, that is it is 330 plus 20 divided by 330 minus 20 into n. So here if I simplify this, we are going to get it as, that is 330 plus 20 divided by 330 minus 20. So if I simplify, I am going to get it as 140 vibrations per second. We are going to get it as 140 vibration per second. That is option C is the correct option. Option C is the correct option here. Okay. So next question similar to that. The driver of car traveling with a speed 30 meter per second towards a hill sounds a horn of frequency 600 Hz. If the velocity of sound in air is 330 meter per second, the frequency of reflected sound as heard by the driver is. So it is similar to the previous question. So you just substitute in the previous question what all terms we have used. Same way you substitute. Therefore, here the correct option, if you use the same formula and simplify it, you will get the option A, that is 720 hertz. You just use the same formula and calculate. Option A is the correct option here. That is 720 hertz. Okay. Option A. Then our next question is the source of sound S is moving with a velocity 50 meter per second towards a stationary observer. The observer measures the frequency of the source as 1000 hertz. What will be the apparent frequency of the source when it is moving away from the observer after crossing him? So the velocity of sound in medium, it is given. Here what is happening? It is moving. We can take two conditions here, when it is moving towards the stationary listener and when it is moving away from the stationary observer. So two conditions we can use and we can calculate the answer. That is, so first I'll do when it is towards the, when source is moving towards the stationary listener, the formula is n dash is equal to V divided by V minus Vs into n. Therefore, this is equal to, so n dash value is 1000, which is given in the sum, is equal to 350 divided by 350 minus 50 into n, which implies n is equal to, just simplify the equation for n, you will get it as 857.1. You will get it as 857.1. But here the sum will not end. The next part is when source is moving away from the stationary observer. So when it is moving away from the stationary observer, the formula is n dash is equal to, or you can take here n double dash, just for your understanding. N double dash is equal to V divided by V plus Vs is equal to 350 divided by 350 plus 50 into n. So into n value is, just now we have calculated, it is 857.1 is there. So we can round up and take it as 857. Therefore, n double dash is equal to 750 hertz. The correct option is option A. Option A is the correct option. Okay. Next question. A source and listener are both moving towards each other with a speed V by 10, where V is the speed of sound. If the frequency of the note emitted by the source is F, the frequency heard by the listener would be nearly. So here they are moving towards each other. Therefore, the formula is n dash is equal to V plus VL divided by V minus Vs into n. This is equal to V plus V by 10 whole divided by V minus V by 10 into n. So this implies n dash is equal to 11 by 9. If you simplify the bracket, if you simplify the bracket, you will get it as 11 divided by 9 into n. But here they have given in terms of frequency f. Therefore, instead of n, I can write it as f also. That is 11 by 9 f. So what is 11 by 9? 11 by 9 is how much? It is 1.22 into f. 1.22 into f. Therefore, the correct option is option B. That is 1.22 f. Okay. Then let us see the last question now of waves chapter. So next question is, a man is watching two trains, one leaving and the other coming in with equal speed of 4 meter per second. If they sound their whistles, each of frequency 240 hertz, the number of beats heard by the man will be equal to. So they are a man watching two trains. He is watching two trains. One is leaving and another one is coming. Both are coming and going with the same speed, that is 4 meter per second. If the whistle of each frequency 240 hertz, the number of beats we need to calculate here. So how we can calculate? First, we need to simplify. We need to calculate the frequency formula. See how we can do this. That is the apparent frequency due to train which is coming. So due to train which is coming, the formula is N1 is equal to V divided by V minus Vs into N. Okay. Due to the train which is going, that is given by N2 is equal to V divided by V plus Vs into N. Therefore, number of beats is given by, so number of beats is given by, it is N1 minus N2, which is equal to, that is 1 divided by 316 minus 1 divided by 324 into 320 into 240. So N1, N2 we know, substitute the values and simplify it. You will get it as 1 by 316 minus 1 by 324 into bracket 320 into 240. Therefore, N1 minus N2 is equal to, we will get it as 6. That is option A is the correct option. And the last question is, at what speed should a source of sound move so that observer finds the apparent frequency is equal to half of the original frequency? So directly we can take the formula, that is N dash is equal to, it is moving towards, therefore it is V divided by V plus Vs into N. So when the frequency is becoming half, therefore here we can take it as, this implies N by 2 is equal to V divided by V plus Vs into N. Therefore, so simplify, which implies we will get it as, that is Vs is equal to V. We get it as Vs is equal to V here. Therefore, the option D is the correct option. Okay. Option D is the correct option here. That is Vs is equal to, at a speed, at what speed should a source of sound move so that the observer finds the apparent frequency equal to the half of the original. That is when it is of the same frequency as V. Correct, students? So this completes our waves chapter. So keep watching the videos. Thank you.